Good morning, everyone. Welcome to this Oracle RAC course. Today and tomorrow are going to be 2 demo classes, and then followed by we'll start the regular classes. Right. So as you can see, this 23rd and 24th are going to be 2 demo classes. I'm going to just brief on course content and then some of the basics of RAC, and then what all prerequisites needed to get enrolled with this particular RAC course. And then followed by we'll start our regular classes from the next weekend. That will be on 30th April and then 1st of May. This course is going to be on a weekend batch of Saturday and Sunday, 4 hours on each day. Saturday and Sunday, 4 hours on each day. Pretty much this is going to take around 6 to 7 weekends. If I open my course content here, directly I'll go into my course content. Before that, if you see this course duration and course details, this course is going to be only on Saturday and Sunday. It's a weekend class, and then it will be like 4 hours on each day. Saturday 4 hours and Sunday 4 hours. That's going to be an 8 AM IST. Right now this is the current time, 8 AM IST to 12 AM IST. That's a 4 hours. And then the course is pretty much going to take around 6 to 7 weekends. Based upon the how we progress, and then the course fees is going to be 15K Indian rupees. Quickly, I can jump into that course content. Probably if, you might have already gone through this course content. We'll start with the introduction to the cluster, where we'll understand the differences between standalone and then the RAC databases, and then what are the basics requirement for your RAC deployment, what are the networking concept, how many VLANs, how many physical IPs, virtual IPs, scan IPs, all are needed. So everything we'll see some of the basic understanding, and then followed by your architecture, where we'll try to understand each and every background processes, and then the cluster daemons, and then cluster services along with your RAC architecture, and then your OCR and routing disk, and then your cluster startup sequence, how your RAC cluster is going to start, and then how your RAC cluster is going to shut down, what is the order, what are the dependencies we're going to see it over here. And then followed by your Linux installation. You want to set up your 2-node RAC, 3-node RAC. Before you start with your RAC setup, you have to install your Linux and you have to configure your some of the networking. So we'll start with the basic understanding of how you can install your Linux from the ISO image, where you can download your ISO image. And then once you install your ISO image, what are the post installation tasks, how you're going to create your grid user, Oracle users, and then the softwares, and then how you're going to create the directories and permissions and the prerequisites RPMs, and then the kernel parameters. All we're going to see it over here. Once we create one particular node 1, and then you can clone that particular VM, and then you can do a multiple copies of that node 1, node 2, node 3, and then your nodes are ready, and then you can start with the RAC installation. So once your multiple VMs are ready here, assuming that your node 1 and node 2 are ready here, and then we'll start with the networking configuration for those VMs. We have to configure our DNS server. We have to configure our public IPs, VIPs, scan IPs, and we have to configure some shared disk between those 2 VMs. And then once you create a shared disk, and then you can, using Oracle ASM library, you can format those disks incompatible with your Oracle ASM. And then once your networking concept, networking configuration, and then the shared disks are all done, so then we will start with our actual installation. So first we'll start with our grid infrastructure. Once the grid infrastructure is done, and then we'll start with our RAC Oracle home, and then we'll create some of the shared disk groups, data and record, and then we'll start with our database installation. So each of them has its own prerequisites. For example, when you're going with your RAC Clusterware installation, you have to do some system prerequisite checks, software requirement, and then kernel parameters and users and groups and creation of directories. And then we're going to do run cluffy checks. And then once the run cluffy check is successful, we'll do that SSH equivalence for my grid user. and then cluster installation, and then the post installation. So cluster Cluffy verify, we're going to do that. For the pre-checks, we're going to use run Cluffy, and then for the post check, we're going to use Cluffy verify. And then similarly for RAC Oracle home installation, again, we're going to do the same thing. Some systems requirement check, software requirement check, kernels, users and groups, and then the directories, SSH equivalents for your Oracle user, and then RAC Oracle home configuration, and then some of the post installations. And then later we can use ASM CMD or ASMCA or SQL plus ASYS ASM, connect your ASM instance and then create some of the data and record these groups, and then start with your database installation. Some of the prerequisite tasks, and then followed by your Cluffy DB installation checks, and then Cluffy DB install and DB config. These are the two checks we're going to do it based upon which version of database you're going to install, 11G R2, 11G R1, and then 12C, 19C, whatever you're going to install it over here, and then followed by your database configuration and then the post checks. So this is all this chapter number 5, 6, 7, 8 will pretty much covers your clusterware setup along with your RAC database setup. Once your setup is ready, then we'll start with our RAC admin activities. Like, we'll start with our ASM architecture understanding, and then we're going to start playing with our ASM disk groups, creation of disk groups, and then understanding of ASM internal concept, and then adding a disk, dropping a disk, creating a disk group, dropping a disk group, and then moving data file from one disk group to other disk group, and then what are the ASM characteristics, what are the advantages like mirroring, striping, and then have high redundancy, normal redundancy with external redundancy, and then so many other concepts we're gonna try to understand here. And then what is the difference between normal ASM instance, normal database instance, and your ASM instance, and what are the ASM instance parameters you're gonna see it, what are the ASM metadata, all we're gonna see it over here. And then some of the ASM admin activities all will be covered as part of this ASM architecture. And then also we deep dive into ASM command line itself, because most of the times we'll see disk group operations, administration of my disks and administration of my disk groups, adding a disk, dropping a disk, creating a disk group with external redundancy, high redundancy, normal redundancy, all we're going to see it over here. And then once you drop your disk, how the rebalance is going to happen inside your ASM. And then once the rebalance happens, what's the impact at your database level? How you're going to monitor that rebalance operations? All will be, live demonstrated, and then we're going to see it. What are the main activities involved in your ASM admin guide? And then followed by your clusterware and RAC database administration, CRS-CTL versus SRV-CTL. What are the various commands we're going to use it? And then you are restarting your cluster services, restarting your cluster processes, and then how to restart your node, how to restart your cluster, entire cluster, or how to restart your database, or how to restart your a particular instance of a database. All will be covered over here. And then if you want to reboot any of your cluster node, and then what are the prerequisite checks you're going to see it over here. So all will be like covered here. And then followed by your cluster admin activities, like we are booting disk, OCR disk, how you're going to back up them, how you're going to replace them, how you're going to restore your routing disk, how you're going to restore your OCR in case of any routing disk corruption, OCR corruption, and then OLR corruption, how you're going to restore them, and then how you're going to manage them, how you're going to take a backup of them, all will be like covered over here. And then managing your networks, VIPs, CAN IPs, and public IPs. In case of any IPs goes down, how you can start them back, and then how you're going to move your VIPs, how you're going to move your scan IPs from one node to other nodes. All will be covered as part of your cluster admin activities. And then coming to your RAC database admin activities, we'll deep dive, and then we'll understand about RAC specific parameters. Your cluster underscore database equal to true, that will make your database as a RAC database. How to check your cluster parameters inside your RAC databases. Where is my SP file and P file resides for my RAC database, whether it is locally, it sits under DBS group or inside my disk group. And then how you're going to copy your files from local storage to ASM, and then from ASM to local storage, how you're going to copy your password file, how you're going to copy your SP file, and then how the redo logs and how the undo will be managed in my RAC databases. What are the table spaces in my RAC databases? How the data file will be managed in my RAC databases? All those like will be covered as part of your RAC database administration, along with your cache fusion and then split bin syndrome, and then cluster node is going down and node eviction is going to happen. So in that case, how you're going to troubleshoot all those logs, and your cluster instances are not starting, and then how you're going to check it, which log you're going to start it out. All will be like covered as part of your RAC, or all will be covered as part of your RAC database administration as well as your cluster administration. And then we'll start with your RAC database backups and recoveries, understanding of your backup strategy, and then setting up a backup strategy for your RAC databases, and then taking your full backup, incremental backup, and then differential backup and cumulative backup. And then once you take a backup, and then how you're going to use those backups in order to do a restore and recovery of various scenarios, restoring of your control file, restoring of your data files. And then if you have a RAC database, how you're going to clone that RAC database as a RAC database, RAC to RAC database cloning, RAC to standalone database cloning, various scenarios we're going to see it. In case of any production database goes down or crashes, how you're going to restore, recover your production database. All will be like understand with setting up of a backup strategy along with the restore scenarios. And then listener is going to be one of the common issues, especially for RAC databases, because there are so many listeners comes into picture here when you're dealing with your RAC databases. There are ASM listeners, scan listeners, database listeners, local listeners, and then the remote listeners, and there's a one more ASM net listener. And then often we'll get confused from which location my ASM my database listener is running, whether it's running from my Oracle home, whether it's running from grid home, and then whether it's registered in my Clusterware, whether it's if not registered in my Clusterware, how I can manage my listener. So we'll try to understand each and every listeners in my Clusterware, and then what is the importance of those particular listeners, what ASM listener will do, what ASM underscore net listener will do, what my local listener will do, what my database listener will do, how I can register my database listener with my Clusterware, and then how I can change my listener port, how I can use my database listener using SRUCTL, how I can manage my database listener using SRUCTL. All will be like covered here as part of your listeners and then listener understanding. And then we'll start with multi-tenant architecture. We'll see that architecture, basic architecture, what is CDB, PDB, and then once we understand the architecture of multi-tenancy, CDBs and PDBs concept, with a detailed understanding internal concept of your multi-tenancy architecture, we'll try to create some of the PDBs with the RAC databases. We'll create some of the CDBs as the RAC databases, and then we'll try to install some of the PDBs as the RAC databases, and then we'll try to start only one instance of PDBs. We'll start all the instance of RAC PDBs, and then we'll try to clone those PDBs from one CDB to other CDB, and then we'll try to plug and unplug, and then there's a various methods to clone your PDBs. All will be covered here as part of your multi-tenant architecture. Again, understanding of multi-tenant architecture is quite difficult because you have one set of your SGA, one set of PGA, one set of SP file, one set of listener, one set of control files, one set of redo logs at your CDB level. And then how my PDB will be act, and where is my PDB level SGA, where is my PDB level control file, where is my PDB level password file, where is my PDB level SP file or P file. All those questions will be there when you are dealing with your PDBs and CDBs. So once we start with this multi-tenant architecture, so all will be like covered, how that architecture works. There's only one set of these files at your CDB level, but your PDB will be subset of that CDB, and then it will gonna use your PDB's resource, your CDB's resource, and then all the PDBs will be managed inside of your container database. All will be like explained and covered and live demonstrated everything as part of this particular chapter number 16. And then we'll start with our ACFS configuration, because most of the time when you are working on RAC environment,
many customer will try to use this ACFS feature because you are going to use your disk group, and then you can mount that disk group as a normal local file system, and then you can place any of your application related files over there. And in fact, you can even create your database inside your ACFS file system. And then once your ACFS file system is created, you can take a snapshot backup of those ACFS file system. We'll try to understand architecture of ACFS file system and what is the use of ACFS file system, and then how to configure that ACFS file system in your RAC databases, and then what are the administration activities in your ACFS file system, and then how you're going to manage your ACFS file system, how you can mount that ACFS file system, and then how you can unmount it, and then what are the various commands, and what is your volume. Once you start dealing with your ACFS file system, you have to understand volume concept, your storage volume concept. All will be covered here, and then we'll be configuring one of the sample ACFS file system, and then we can see that how you can mount it in local your laptop, or how you can mount that ACFS file system inside your VM as a file system, and then you can copy paste whatever command, normal OS command, you can do it inside its ACFS file system. And then there's a RAC one node, not much, not widely used, but we'll try to understand what is this RAC one node, and then what's the difference between RAC one node versus RAC database, and then how you can relocate RAC one node from one node to other node, and then what is special about RAC one node. So we'll talk about that. There's other database also along with this RAC databases. Your Oracle Restart database, standalone databases with file system and with ASM, RAC one node databases, and RAC databases. Various databases. We'll try to understand RAC one node, and then if time permits, we'll try to cover the other database types also. And then we'll jump into patching activities, because patching exercise is one of the common activity for a DBS. So we'll try to understand patching because when you're patching your standalone databases, is quite simple and easy. You can easily apply the patches. But when it comes to RAC databases, there are various methods of patching: rolling patching, non-rolling patching, and then online patching, and then how to minimize the downtime during your RAC database patching. What are the best practices? And then when you're patching your RAC databases, you have to patch your clusterware. You have to patch your ASM home first, and then later you have to patch your RAC Oracle home. Once you patch your ASM and Oracle home, and then you have to run the data patch at your database level. How you're going to do that rolling patching without impacting the other database instances? Suppose you have a 2-node RAC, and you have to keep your node 2 online, and then application will be connected to that without impacting node 2. How to bring down only node 1, and then apply the patch on that node 1, and then bring it up, and then go to node 2 and then patch node 2. How you can do the rolling patching? That's one of the common patching activities. We'll understand what is OPatch versus OPatch auto. So you can apply the patch by manually using OPatch. You can apply the patch using OPatch auto. And again, there is a various concept. What is OPatch apply, OPatch n apply, and then after that we'll apply the patch on my clusterware on my ASM home, and then apply the patch on my RAC Oracle home, and then RAC databases, and then later we'll run the data patch. So we'll see this entire patching activities, because this is common activity in a DBA world. And then we'll start to understand my database upgradation, especially RAC database upgradation. What are the pre-checks, what are the post-checks, and then how you're going to upgrade your RAC databases. There's various methods to upgrade your RAC databases. You can upgrade using DB upgrade, or cat upgrade.sql, or using DBUA, or you can use your auto upgrade. 19C feature is auto upgrade. You can use auto upgrade. So we'll try to cover all of them, all of those various methods of your RAC database upgradations. And especially we're going to talk more about clusterware upgrade. If you have a 12C RAC or 12C clusterware, and then how to upgrade that 12C clusterware to 19C. And then you're going to do that out of place upgrade. In place upgrade is not supported here. Anything, either whether it's a database, or whether it's a RAC database, or whether it's a standalone database, or whether it's a clusterware, we don't support in place. Always upgradation is going to be out of place. You have to install the new binaries, and you have to start your upgradation. And then node addition and node deletion, one of the common activities if you're working on enterprise organization. Right now you have a 2 node cluster, and then your business is growing. You want to add one more node. You have to make that 3 node cluster. How you're going to add the node? And then you're right now having 4 node cluster, and then unnecessarily one extra node is sitting idle. You don't want to pay for the resources, and then I want to remove that particular node. How to remove that 4 node cluster, remove that one node and make it as a 3 node? That node addition and node deletion, we're going to do it here. And then it will cover some of the pre-checks, post-checks, and what you need to understand, what are the precautions you need to take care before adding and deleting the node. And then uh, we'll be using converting single instance to RAC instance. You have standalone databases running here. How to convert it as a RAC database? You have various option to convert your standalone database to RAC databases using DBCA or using your OEM, or even you can use rconfig and you can convert it. So we'll see this how you can convert single node to RAC database, or even there's manual steps you can manually add the instances. That's pretty much about our course content for this RAC. And then at the end, we're gonna see some of the resume and cover letter. And then we're going to demonstrate on my resume and cover letter. You can pretty much use that template, and then you can edit your resume and then upload it. And then along with this course, we're going to regularly talk about some of the commonly asked interview questions and answers. If you have faced any questions or queries, we're going to discuss this regularly on that. And at the end of the course, it is again subjected to your interest. If you're willing to take a mock interview, you have to register, and then we'll connect one-to-one, and then we'll try to take some mock interview experience, and then we'll see how much you gained and then how confident you are in that. Right, so that's pretty much about the course and course content, what we planned. Any questions on that? Feel free to unmute and then ask it. And then this is the planned course content, and in case any particular topics or anything you need to add it as part of this course, you are always feel free to give your feedback, and then we'll take those topics along with the course or at the end of the course. Right. Great. So any questions or queries before I go ahead with the further topics?
Yeah, Malik, is there any scope to for DR English data guard covering?
Data guard pretty much I covered. There are like many recorded sessions. I already covered one rack to rack data guard setup. I think probably one of the live webinar I took publicly. I think many people are joined. Also, it's available in my YouTube. I just did a complete rack to rack DR setup from the scratch. Probably you can watch that video. I can take that as a one extra topic here. I can demonstrate rack to rack DR setup. Probably no issue in that. We can take it as a one extra class.
Yeah, okay.
I can include that topic. It's pretty simple. If you just understand the basic concept, and then you can pretty much set your RAC databases and DR databases. That too, especially rack to rack.
Sure.
All right. One more time, this is going to be only on Saturday and Sunday, and then every Saturday and Sunday it will be like 4 hours classes Saturday and 4-hour classes on Sunday, 8 a.m. to 12 a.m. IST. It will be in IST 8 a.m. to 12 a.m. Actual class is going to start by next weekend, 30th April, and then followed by the consecutive weekends, 30th and then 1st of May, 7th and 8th, 7th and 8th, and then 14th and 15th May, 21st and 22nd May, 28th and 29th May, and then 4th and 5th of your June. So pretty much by 4th and 5th, we may complete, or if not, then we'll take one more weekends. And then probably the advantages of weekend classes is, the moment if I cover 2 or 3 topics for one weekend, you have entire week to practice and then ask any questions. So why I'm taking especially these classes as a weekend, because each and every topic, whatever we're going to talk, for example, if I start with the RAC installation or the Clusterware installation, it may take more than 2 hours, 2.5 hours. We cannot complete within 1 hour or 2 hours. So that's where, the idea behind taking a classes on the weekend, it'll be like, the top, each and every topic in the RAC, especially, it will be like huge. We may face a lot of issues because Slack setup and understanding of RAC is not that simple. Even though you did a multiple times practice, whenever you try to do a next time, again you will face a new issues, and you have to learn from that, and you have to fix it, and you have to get going ahead with that. So because of that, we are be like taken it as a weekend classes, and then we initially planned it for 8 hours in a day, 8 hours on Saturday and 8 hours on Sunday. I think I got a feedback that 8 hours is too much, and then we restricted to 4 hours, and then pretty much we cover around every weekend, Saturday, Sunday, 4 hours, 4 hours, 8 hours. We may cover around pretty much 6 to 8 topics, and then probably you will get the entire for next 5 days to practice and then ask many questions. Before we start the next topics in the next weekend, right? That's the idea behind that. Right, and then you can regularly refer my blog. Probably I'll be posting Malik034 blogspot.com. I'll be posting some of the technical guidance. Regularly, I'll be writing some of the technical posts. Probably you can regularly follow my blog, and then you can see some of the technical ideas out of that. And already told many people, like, writing your blog is one of the very, very important skill, where it will improve your skills, as well as it will improve your technical writings, and also uh, it will help you to refer in single point, rather than you search into the Google and then get the commands and other things. You just start writing your own blog, and then start putting whatever you work in day-to-day work. Just today you get a request to create a sample users, and then you're going to create a users, and then just copy whatever the command you're going to use, whatever the output, just copy it everything, and then write it in your blog. And then later you can refer it by your own purpose. You don't need to impress anyone, right? You just keep on writing blog by yourself, whatever you work in day-to-day life with the simple topic or whatever topic, you start writing it, and then keeping it inside your blog, and then you can use it, you can refer it by your own. You no need to ask everyone to refer, but you can start writing your own blogs, and then you can start using that by your own. And one of the advantages is, for example, assume that if you're working in a client environment, you are going to sitting in front of your client, and then you are supporting for your client, and then client will give you some of the tasks, like create user. As a DBA, remembering commands is very difficult. Even in fact, I will not remember any of those within the even it is a simple command, I will not remember it, because every time many tasks comes, I'll just get a command from the Google, and then I can modify accordingly what I need, and then I can execute it. So assume that you're sitting in front of your client, and then if you get a create user request, and then you are opening a Google and checking a command, create user in Oracle, and then client will think, whether you are a good DBA, or whether you have experience, or whether you are expertised in database or not. Like, those are negative thoughts will comes into their mind, right? So that's not a good impression. Uh, think in a different way. Like, again, you will get the same create user command, and then you're sitting in front of the client. Instead of opening the Google, and then you'll pretty much open your own blog, and then the moment you open your own blog, and then you can get the command, because in your own blog, where you kept all your commands, and then which pretty much if I go, I know database. If I go, I will just go to database, and then I can get whatever the command, whatever the topic I want it, and then I can refer it. The moment you open your own blog in front of your client, and then that's a first impression to your client. Then they will think, okay, this guy is brilliant, and then he's writing some technical content, and then he is helping Oracle community. This is like, advantages to you, as well as, it will be like showcasing yourself in front of your clients, or in front of your management, or in front of your team. That's a small things, advantages of writing your own blog. And then once you start writing your own blog, what happens? All the commands, you know where you kept it. And then once you know where you kept the command, easily directly go and then get the command and then complete your task. That's the other thing. And then the third thing is, once you start writing your blog, and then if it's a public blog, obviously blogs are all public, and then other people, other Oracle community will be start referring into your blog. Once your blog is referred by other users, and then if you're writing a quality content, many people will be start liking your blog, and then all the traffic will start coming into your blog. Once all the traffic is start coming into your blog, then you will be getting recognized by the Oracle community. Once you're getting recognized by your Oracle community, people will start reaching to you with small queries and small doubts. And then once you start answering to those queries and those doubts to your Oracle community, your confidence level will get increased. And then once your confidence level get increased, and then there are a lot of things will happen, right? Your small initiation, this is a small initiative. You are started writing your own blog for your own help, to get your own knowledge and boost your own knowledge. And then at the back end, it will give you a lot of advantages, like impression in front of your management, in front impression important, like impress your clients, impress your teammates. And then you are getting recognized by your Oracle community. So those are, like small advantages by writing your own blog, right? So you no need to invest, you no need to do a lot of research. Whatever you work in day-to-day work, the moment you will get a export and import request today, create your own export command and do a export. And whatever you get the logs, whatever the command you executed, just copy everything, and then remove whatever the sensitive data, the IP addresses, host name, or whatever that, remove that sensitive data, and then upload it into your own blog. You can refer it anytime, and then you no need to search it in Google. That's the advantage of blog. Again, like, all the blogs are free. You can go with any blog, many vendors which support free blogs, and then start writing them. Right. So that is deviating from our topic, but yeah, one of the good key point you can remember. But then keep following my blogs, so you'll be getting some of the technical content. Also keep referring my YouTube channel. So there will be a lot of content in my YouTube channel. Probably you might have all aware that there will be like a lot of content with respect to database, data guard, security, and then patching, your database upgradations, your clusterware. There are so many contents in my blog, my YouTube channel. If you're not aware, go back, and then whatever you need, like it, you can just watch that. And then we do have a public Telegram group where you can post any questions, queries. Many people will be like answering your queries. If not, then I'll be regularly watching that, and then I'll be able to answer that. That's a public one. So, but on top of that, whoever joins this particular RAC course, we have a dedicated WhatsApp group, and then we'll be communicating each and queries, whatever the questions, doubts, everything will be like discussing in our WhatsApp group. And those WhatsApp group will be like forever. We can post any queries, questions, and anything related to your job, and anything related to your job support, whatever task you're getting in your day-to-day work. And if you're not able to proceed further, if you're stuck, you can feel free to post it in our group, or post it to me in one-to-one. I'll be guiding you. I'll be like, helping you to proceed further with that particular task. And then everyday sessions will be like recorded here. Whatever we cover will be like recording all the sessions, and then we'll be uploading it to Google Drive. And then you can pretty much uh, uh, access all the materials, all the quiz, workbook, PPTs, labs, everything from your Google Drive. And then in fact, even you can download those videos and materials into your local laptop. No restriction at all. All those you can download it locally on your laptop, or you can refer it in our Google Drive itself. Those videos, recording sessions, and then the workbook, PPTs, materials, everything will be available and accessible for lifetime support. And then pretty much once you attend this course, in case if you want to re-attend this course in future batch, so you can feel free to attend. No need to pay extra amount on that. It's like one-time registration. You can attend a number of times, no issue at all in that. Right, so pretty much this is a course content, what we discussed so far. And also one more time, like, the course fees is going to be 15K, that's Indian rupees. That's going to be on weekend batches, right? And then like some of the advanced topics, as we see, like RAC to RAC DR setup, we'll take it as one extra classes, as we just discussed. Some of the OEM alerting mechanism will take it as extra classes. And then some of the data guard, broker, and wallet security concept, and some of the Oracle licensing, we'll take them as some extra classes after this course. Right, and then pretty much we'll be uploading everything into our Google Drive, where you can just download and then you can use them. Like if I open here my Google Drive, pretty much you can go to your RAC course material here. You have your DR docs, you have your some of the RAC notes or RAC books, all the RAC commands, everything you're going to get it over here. You can go here, RAC PPTs, you'll see all the PPTs over here. And then RAC internals, you can see a lot of internal concept, you're going to see it over here. And then some of the RAC specific RMAN scenarios, you can see it over here. Everything will get access on this one. And then your GI and database patching, and then RAC course PPTs, your RAC course materials, lab exercise, each and every lab, whatever we're going to see, each of them will be having its own specific command. You're going to start with that command, and then we're going to install it in our own lab, creating the users, home directories, and then start with the installation. And then all of them, like, these are like lab commands will be like taken it, executed in day-to-day labs. And then we do have a ready VMs and labs here. Like, you have a, you can see this one here, right? RAC setup. This is a 2-node RAC setup with a grid user and then the Oracle user. You can see grid user and Oracle user here. And then we have a RAC setup with ASM and database with the Oracle user. With a single Oracle user, we have installed 2-node RAC with ASM and databases. We have just a ASM installation, 2-node RAC setup with the ASM installation as a grid user. So you can download this one and then you can practice your database installation. And then we have a 12C RAC setup with ASM as a Oracle user. You can use this 12C RAC setup and then you can practice your Clusterware upgradation 12C to 19C. So all these are like ready labs which are already readily available. I can just download it and then you can just set up in your own lab, own laptop or desktop, and then you can practice it. So yeah,
We don't have any.
your voice is low, Srinivas. Hello.
VHP files is not there.
Sorry, come again.
This is for Oracle. This is for not for Windows VMware, right?
This is for your Oracle VirtualBox on Windows. You have to install your Oracle VirtualBox. This is your Oracle VirtualBox on Windows. Whatever version, Windows 7, 10, 11, whatever it is, you have to download this Oracle VirtualBox, and then you have to download this lab setup, unzip it, and then you can configure here. You can get your labs here, node 1, node 2 RAC setup.
How to attach it? Can you show us?
I will show it, like once we start our actual classes, I will show this one, how to use this labs. And pretty much we have here, like, if you go to this RAC recordings here, if you go to this prerequisite session here, right? In this prerequisite sessions, you can see ready lab setup with the grid, ready lab setup. These are the videos of how to download it and then how to attach it here in this lab. So already these prerequisites recordings are all available here. You just need to watch them and then you will understand how we can download. Even once we start our classes, I will show you that one demo. But pretty much I explained here with each and every lab how you can download it and how we can attach it here. And then this is our new batch here. The moment all the recording will be uploaded here, we'll be referring this Oracle RAC course material and then this RAC course recordings. These are the two folders I'll be giving access to everyone once the course is started. And then this course RAC course materials, you will see all the content, all the ready VMs, all the PPTs, all the lab exercise, all the workbook, all the materials you'll get it here. This RAC course material. And then in this RAC course recordings, we do have these pre-recorded sessions where you can see how to use that labs, how to set up in your own lab. You can just watch them, or like I'll show you one demo once we start our actual class. And then daily recordings, I'll be uploading it over here, so you can easily refer it in one place.
All right, so that's about RAC setup, how you can access it, and then how you can do it. In fact, we'll be doing the RAC setup from the scratch so that you'll understand it and you can do it by your own setup. So why one of the advantages you should ask, right? Like, why these ready labs are available here, right? For example, if I go back to my course here, uh, like in order to set up your RAC, it will start it from here, chapter number 5, and then it will go up to chapter number 8 here, chapter number 5 till chapter number 6, chapter number 7, and chapter number 8. So this chapter number 5, 6, 7, 8, this entire setup will give you a 2-node RAC setup, complete 2-node RAC setup. In order to do this entire 5 to 8, at least you need 1 day. If you're doing for the first time, you need at least 2 days. If you already done it, you need at least 1 day in order to do this entire RAC setup. And then once your lab setup is ready, assuming that you're doing some restore, recovery, and upgradation, all those scenarios, and you may end up with corrupting your lab. You may end up with your lab may get crashed, and then again you have to delete everything. You have to start it from the scratch. So you don't have another 24 hours to do entire setup here, right? In that case, just directly download these labs. Just download whatever lab you want locally, and then unzip it, and then attach it to your Oracle VirtualBox, and then you can start practicing your whatever the task you want to practice, either upgrade, migration, cloning, or whatever task you want. You can just do it. So that's the beauty of these ready labs. Just download it and then use it. Within few minutes your lab will be ready. Right, so that's about your lab access. And then before getting started with this RAC course, some of the prerequisites is you should assume that you are aware of your Oracle architecture. If you don't know your Oracle architecture, probably you may feel quite difficult understanding of RAC, because uh, without knowing Oracle architecture or Oracle basics, it's very difficult, especially for RAC. You have to spend many more hours, many time, and then you have to get your knowledge. You have to understand the database architecture. You have to understand what are the basic database admin activities. And then you have to understand your ASM storage, because you're going to store your data files, control file, redo log files, archive log file, everything inside your disk group. And then if you don't know the disk group, then probably uh, that will be like challenging. So anyway, like we'll be covering some of the ASM concept here. Uh, we'll be covering in deep dive of your ASM concept here. There you will understand your ASM and storage concept in very well. If you don't know your ASM also, that's fine, because we'll be covering it here as part of this RAC course. And then you should know your basics of RMAN. Like, if you don't know the basics of RMAN, what is RMAN? And if you don't know what is RMAN, then probably RAC is going to be like little difficult, right? Because you know the RAC, you know RMAN, how to connect to RMAN. If not, then you'll feel that little difficult here. So this is like some of the prerequisite checks. At least you should aware that what all these, and then you can easily understand the RAC. Otherwise, you have to spend more time to first understand them parallelly with this RAC codes. Right. So I'm not going to cover this basics here, because this is already covered as part of my database course. We'll cover it once we start our actual class. Right now, today I will just do some introduction to this RAC and the standalone. What are the differences? And then tomorrow we'll see some of the RAC services, background processes, and then the startup sequence and other things. Today I will just do some introduction about the clusterware and then the architecture wise. These are pretty much a few topics I wanted to discuss in these demo classes. The differences between your standalone and then the RAC databases, and then Oracle clusterware configuration. What is your ASM? What is your clusterware? What is the client connection to database? How the client connection to database works? And then what is the RAC shared storage? What do you mean by shared storage? And then what are your RAC background processes? And then where do you see your control file, redo log files, database files, SP files? What are your voting disk and OCR, and what are its component? And then what is your OLR, Oracle local registry? Oracle clusterware startup sequence, and then how to find out whether it is a RAC database or standalone databases. And then what are your clusterware troubleshooting logs? These are like basic topics. I just listed it out as part of these demo classes. We'll see few of the topics today, and then few of the topics tomorrow we'll discuss. Right. Differences between your standalone database and RAC databases. Pretty much these are just writings. You can just read through it. Standalone databases is just like one-to-one mapping. RAC databases is like one-to-many mapping. What that mean by one-to-one and one-to-many mapping? Let me open here. Right. So okay, before this one, I'll just open our. Give me a second here. I'll just explain it in simple words. Meantime, any questions anybody has particular to this course or any queries, feel free to ask. Right. So right. So this is what it works here. If you see standalone versus RAC, standalone is like one-to-one mapping. You have one database server, and then you have one your storage server. Like one instance will map to one database. The database is nothing but your actual storage where you are going to store your data files. That is your database, actual database where you're going to store your actual data, all your data files where it's going to resides. And then your instance is the one which will be running on your database server. Any connection has to go to your instance, and then it has to connect to your database. Database means your data files. It's just like in standalone, it's like one-to-one mapping. Your one instance will map to one database. I have my database one, I have my database two, D1 and D2. I like it's a dev DB and then it's a test DB. I have two databases. Dev DB has its own data file and test DB has its own data files. And then I have one instance which is mapped to one dev database. I have another instance which is mapped to my test database. Like it's one-to-one mapping. You cannot have this a single dev database pointed to your dev database instance or test database instance. We cannot map that one because each database will be mapped one-to-one here in case of your standalone. In case of your RAC, what happens? You have multiple instances. For example, this is your Linux server A, Linux server B, Linux server C. These are like 3-node. We can say that 3-node RAC cluster. We have a database software is installed on all of these three. And then we have started our ASM instance as well as our database instance here. So database instance 1, database instance 2, database instance 3. All these three database instances will be accessing a common database. That is your DevDB, TestDB or ProdDB, which is resides under a shared storage. This shared storage will be accessible by the server A, server B, and server C. This is becoming your 3-node cluster. All these three instances will be able to access my database, which is shared storage, which is in shared storage. And then that storage will be accessible by all of your cluster nodes. This is your RAC setup, or this is your Clusterware setup. It's like many instance mapped to one database. It's like many to one mapping, but your standalone is like one-to-one mapping. One instance is mapped to one database. That's your data files. We can call it as a database. So that's for your understanding of your standalone versus RAC. A single instance database to have one-to-one relationship between your database and then the instance. Database, don't get confused. Database means your actual data files residing under the storage. It's like one-to-one mapping. And then RAC environment has like one-to-many, like one database mapped to many instances, or many to one, like many instances are mapped to one database. Means one database storage where your data files resides. Right. And RAC database have like up to 100 instances. I don't know if that's limitations for RAC, but I need to get it. How many maximum instances we can create in RAC Clusterware? 10, 100, 50. I have seen it maximum instances of how many? I have seen it 16 instances for one of the customer in my career. They had a 16-node RAC, but what's the limitation? Not sure. We need to get on that.
you can pretty much go with multiple nodes, right? And then some other characteristic of your RAC database are RAC is configured with multiple instances running on many nodes. As you can see here, like these are like multiple instances, instance 1, 2, 3 running on many nodes, and then they all will access the same common shared storage, right? So you can see here, right? These are like instance 1, 2, 3 all will be accessing a common shared storage. Right, so I can just quickly give a demo on that. I have here ready lab. This is a 2-node lab here. I'll just clear it out. Just to ps-ef grep s1. Okay, pretty much your node 1 is down. ps-ef grep s1. Okay, you have your node 2 is ready here. Node 2 is running here. You have your ASM2. Node 1 ASM is down here. I was doing some maintenance activities. These two nodes, you can see your Vara prod 2, instance 2 is running here, and then your Vara prod has to run here on node 1. Both instance, like for example, this instance 1 and instance 2 accessing your common storage. That's your RAC beauty. RAC is configured with your many instances mapped to single databases. Multiple insights resides on the different nodes and communicating each other. For example, this instance 1 and instance 2 will communicate with each other using your cluster interconnects. And then that's where, for example, we have a cache fusion. We can call it as a cache fusion. Some user connected to node 1 here, instance 1, and then he ran select star from employee, and then where employee ID equal to 100. And then that employee 100 information from the data file will go to instance 1. Instance 1 is nothing but, that instance is a combination of memory plus background process, right? It will sit it in this SGA here. It sit in the buffer cache here, database buffer cache. That employee ID 100 information will sit it here in this node 1 buffer cache, and then he will get that result, that end user. Assuming that one more user connect to instance 2, he will run the same query, select star from employee where employee ID equal to 100. And then how this particular user will get the information is that query goes to database and then fetch that database user 100 information, and then again comes to my instance 2 and then sits here in this buffer cache. No, that will not work in the RAC. That's not how it works. The moment the user connected to node 2 will run the same query, it will go to your instance 1 and it will fetch that employee ID 100 information, and then it will copy it to your instance 2 buffer cache, and then it will be given to your the user who connected to instance 2. No need to fetch it from the data file. It will already available in the buffer cache of your instance 1. Directly that block will be transferred to your instance 2 and then kept it under buffer cache of instance 2 and then given it to that end user. Very, very fast, because accessing from memory to memory is much more faster than accessing it from your disk, because here you need a disk IO. Here it is from memory, RAM to RAM, like buffer cache to buffer cache. So directly that block from the instance 1, it will be copied to instance 2 and then given it to that end user. That we can call it as a cache fusion. So one of the common interview questions they will ask, what is cache fusion? Cache fusion is nothing but accessing the database buffer blocks from one instance to other instance if it's already available in that buffer cache, right? That's your cache fusion. So that we can communicate, we can call it as a node communication, which will happen through private network. We have a private network between node communication. All the blocks or intercommunication will happen through that private network. And then read through all of this. We have a parameter called max instances. We'll set it out, and then instances can share the common files, your control files, your what are the common data files and what are the you may ask, right? I said it's a common storage, and then your data files are common. Your instance 1, instance 2, instance 3, for all of these instances, your data files are common. For example, your data files and your control files, your parameter files or SP files or your password files. These all are like common across all the instances. But when it comes to your redo logs, instance 1 has its own redo log, and instance 2 has its own redo log, and then instance 3 has its own redo log. Why, you should ask, why redo logs are individual to node, and then other things like control files and data files and other files are common across all the instances? That's a common question, right? Because if instance 1 goes down, any transactions are happening on my instance 1, it has to log or it has to write to its own redo logs. And any transactions are happening to my instance 2, it has to write it on its own redo logs. Any transactions are happening on my instance 3, it has to write it to its own redo logs, right? So that's where redo logs are individual to your instance wise, so that any instance crashes, we can read those redo logs and then we can do that instance recovery, crash recovery. But apart from that redo logs, if you consider your control files, data files, your password files, your SP files, all are common, which is said and then available inside your disk group. There is no individual concept for other files except your redo logs. Right, so that's where it written here. Just read through that, and then I can directly jump into the differences between uh, my RAC versus standalone with accessing, how it works. Uh, in case of your standalone and in case of RAC, ideally in any industry, if you go, it's always 3-tier architecture. The front end, uh, we can call it as the front end, or the client, web or mobile or presentation layer. This is a front end tier or front end layer. Anybody can access application via URL, browser, or the mobile devices or the desktops. Or the middle tier is the logic, business logic will run here. Middleware is the one where the business logic runs. Your application servers will run here. We can call it as a middle tier, middleware, app server, web server, or your business logic, or any application layer, anything you can call it here. That's where your app server comes into picture. And then backend is your database. We can call it as a backend or database tier or data management tier or whatever it is. It's a backend here, your database. Like anybody connects from URL, mobile or application, all the connection will go to your app server. From the app server, it will connect to your instance here. This is your Linux server. Instance is runs under any of the Linux server, right? All connection will go to your instance, and then via instance we'll access our database. This database means your data files, which is resides under any of the file system or your ASM storage. If this particular instance goes down here, I'll take annotation here. If this particular instance goes down here, what happens? All the connections, all your applications, all will be like gone. Nobody is able to access your data files. Even though your data files are available in your storage, nobody are able to access it because the instance is went down. That's a standalone database. What happens in case of RAC here? Anybody connected via URL or mobile or desktop will go to their application server here. From application server, anybody connected via app server 1 will go to instance 1, or it may go to instance 2, or it may go to instance 3. Based upon your scan, it will go to any one of the instances. Or anybody connected from mobile or desktop will go to connection any one, instance 1 or instance 2 or instance 3. Anywhere it will go. And then what happens if this particular Linux server goes down here? The URL connection from app server, it connected to instance 1. Automatically, RAC has a failover concept. The connection will go to node 2, and then it will be connected to node 2 here. And then what happens if the node 2 goes down? And then automatically the connection will go to node 3, and then it will connect to node 3. And then he can continue to run his queries, and then continue to do whatever operation he wanted to do. That's the beauty of your RAC. In case of any one instance goes down, automatically it will fail over to any surviving node. That's about your RAC beauty, right? Let me clear this one here. Right. That's a RAC, how it works here as comparison with your standalone. In the real time, if you compare, this is the backend architecture what I written, but if you compare with your real time world, you have a client which will be like connecting to your database via public network, and then via public LAN or public network, you will connect using the scan or the VIPs. The moment he connects, The connection will go to any one of your cluster nodes. You have a 4-node cluster here, node 1, 2, 3, 4. The client connection will go to any one of this node. As I say, like, he may connect from URL or mobile or desktop. The connection will go to any one of the node, Once the connection goes to any one of the node, and then he can able to access storage. That's a shared storage, which is attached to all of the cluster nodes. And then he can access it, and then he can run any of those queries. That's how it works. Your standalone versus RAC with a connection to your end user or the clients. And then go deep dive further into that RAC connection. I can explain further more here. You have a client user, they're connecting using mobile or URL or internet, or it may be desktop application. He might be connecting here. The moment they connect here, right, they may use any one of the like front end application. They will connect, any client may connect. And then how this front end connection will work? They will be using this scan connection here. The scan connection, you can see we are using this RAC 12C. This RAC 12C will be internally pointed to your scan name here. The moment they connect using scan name, their connection will go to any one of the cluster nodes. For example, this is your RAC scan here. They will be using this RAC scan in the TNS names here. The moment they use the RAC scan, RAC name here in the TNS files, the moment they connect using this TNS file from this application server, and then the connection from any of this front end connection will go to your app server. From that app server, that application team will be using this TNS details. That TNS details will be having your scan server name here. And then that scan server name will route the connection to any one of this node. Your RAC node 1, node 2, node 3, node 4. The connection will go to any one of this node because they're using a scan. Scan will resolve to any one of these nodes. And the moment the connection will go to any one of these nodes, from that connection, they will access your shared storage. The database resides under your ASM disk group. They will access our database, and then that end user will get the result. And then there are, 3 or 4 network layer here. Whatever that front end user will be accessing a public network. And then whatever the scan name, you can see the scan name 192.168.1.200, 300, 400. These are the 3 scan IPs I'm using here. 192.168.1.200, 192.168.1.300, 192.168.1.400. These are the 3 scan IPs here. These 3 scan IPs are VIPs. And then those are like, publicly accessible. The VIPs are in public network. And then whatever that end users are accessing, those are like public network. And then each node has its own IP here. You can see 192.168, 1.1 and 1.1, 1.1.2, and then 1.1.3, and then 1.1.4. These are your public IPs. And then these are your physical IPs. These node IPs are public IPs, and then the physical IPs associated to that individual nodes. And then each of those nodes will be like physical IPs and then attached to your interfaces. And then you have a 3 scan IPs, which are VIPs. Again, they are also in the same public network. And then each of these 3 nodes has a VIPs. You can see these are your node VIPs. Node VIPs, you can see 101, 102, 103, 104, and then again 105, 106, 107, and 108. These are your node VIP, like node 1 VIP, node 2 VIP, node 3 VIP, node 4 VIP. And then these VIPs again in the public network. And then these are like, virtual IPs. Your scan and your VIPs are virtual, not a physical. But whereas your node IPs are like, these are like your physical IPs. But underlying fact is all these 3 IPs are in public network. You can see like your net mask here, 1. And then you can see your scan IPs, again, that is also 1. And you can see your node IP, again, that is in 1. So that means all IPs are in same subnet. It means all IPs are in a public network. And then the type of IPs, some of them are physical IPs, some of them are like VIPs. Each individual 4 nodes have its own physical IPs, and then your scan will be having a VIPs, virtual IPs. Your node will be like having your virtual IPs. And then along with that, we have each node has its own private IP. For example, this particular node 1 has its interconnect 192.168. You can see this is a 2 dot and some IP. Node 1 has its own private IP, and then node 2 also has its own private IP. You can see that subnet here 2 dot, and you can see the subnet here is 2 dot. Again, you can see the subnet here is 2 dot. So those private network will be used for intercommunication. This node 1 to node 2, node 2 to node 3, node 3 to node 4. All the node communication will happen using this private network. So that private network is mandatory in case of if you want to set up your RAC clusterware. So let's quickly, I can take one of my lab environment here. I'll try to see it. I'll try to show that one. So right now you got how many, one of the common questions they will ask in order to set up a 2-node rack, how many IPs are needed? How many IPs are mandatory? That's one of the common questions they will ask. Let me connect to my one of the rack cluster node here so that I can show you that.
Hi, Malik.
Yes, please.
The virtual IP and scan IP both are same or how different?
Both are VIPs, but not the same IPs. It should have its individual IPs.
Okay.
Right. So these are my 2-node rack here. PS-EF grep S1. You can have your ASM1 and you have your ASM2 here, and you have your rack standby 1, rack standby 2, and you have test DB1 and you have test DB2. The 2-node rack setup it is. Just to check rack setup here. Okay, let me exit here. Right, so I'll set up my environment to plus ASM first here, ASM1. This is my ASM1. And then if I do OLS nodes, it's one of the common command. If you do OLS nodes, you will see your rack nodes. It's a 2-node rack setup. Oracle node 1, Oracle node 2. This is your Oracle node 1, and then this is your Oracle node 2 plus ASM2. This is your ASM2 is running here. And then this is your Oracle node 2. Again, OLS nodes that will give you what are your cluster nodes. Because if you just to connect to one node, you don't know what are your cluster nodes. You have to use this command OLS nodes. It lists out your cluster nodes. Whether it's a 2-node cluster, 3-node cluster, 4-node cluster. If you are new to environment, you don't know how many node cluster it is, right? Just run this OLS nodes. It will give you cluster node details. Again, OLS node has many appends. You can do OLS nodes -C, -A, many commands. You can list it out. Right, and then if I do ifconfig, right, I have 10.38.4.100. Let's draw it here. This my rack setup. Okay, I'll take this paint here. One of the common questions, if you want to set up a 2-node rack, what all the mandatory IPs are needed here? So I'll just take this as an example. This is your Oracle Lab 1. And this is your Oracle Lab 2. It's a 2-node rack. Obviously, if you want to set up 2-node rack, you have to install your ASM software here. U01 19C grid. And then you have to install the same ASM software here. Again, we'll see it once we start our regular classes. We are doing it from the scratch. If I go here, if I do PS-EF grep S1, you can see this is your ASM software here. User on app 19C grid. This is your ASM software or the Clusterware software. If you do the same command on the other node, you can see user on app 19C grid. Same location will install it, but you have to install that ASM software on both the nodes. Even though it's a cluster nodes, you have to install that ASM software on both the nodes. Once you install, at the end of the installation, we will run that root.sh script. The moment you run the root.sh script, it will club and it will combine your both the nodes, and then it will make it as a cluster nodes. The moment you install ASM software on node 1, ASM software on node 2, those 2 nodes will act as the individual nodes. They will not be act as a cluster nodes. Once you install the software, at the end of the installation, you are going to run the root.sh script. The moment you run that root.sh script on node 1 and node 2, that is where it's gonna make your both the nodes as a cluster nodes, and both the nodes are part of the same cluster. That's until that in both the nodes will act as the individual nodes. That's where the root.sh script will comes into picture. Root.sh script. So that will make both the nodes are part of the same cluster. And then later you're going to install the same thing, U01 19C db home _1. So you're going to install the software, db home software here on node 1, and then you're going to install the db home software on node 2 with the same name, same directory structure. The moment you install the Oracle home on both nodes, this is become your RAC cluster home. If you install only on node 1, you cannot create the RAC databases. You have to install the same database software on both the nodes. That become your RAC Clusterware Oracle home, so that you can install your test db1 instance here, and then you can install your test db instance 2 here. This test db instance 1 runs from this particular Oracle home. This test db instance 2 will run from this particular Oracle home. And then these two test DBs are pointing to common storage here. I can say that data and record disk groups. This is my data disk group here. And then ideally, like it will start with your plus data, and then this is your plus record disk group. Here you have your data files. Here you have your archive log files and redo log files and control files. Both your instances, your instance 1 will be pointing to your data disk group, and then it will be pointing to your record disk group. Similarly, your test 2 instance also pointing to your data disk group, and then similarly it will pointing to your record disk group. Both your instances are accessing the same data files, redo log files, archive log files, control files, right? And then your grid software here, whatever you installed, you just install the grid software, you ran the root.sh, and then it has formed your 2-node cluster here. And then who is going to manage that cluster? You installed your cluster, that's fine, but who is going to manage that cluster, right? That's the other questions. That's where we came up with a concept called plus ASM1 instance here. And ASM instance is responsible for managing your Clusterware. Like, you have your ASM instance 1 here, and then you have your ASM2 instance here. These both the instances are managing your individual cluster nodes, right? This is a typical 2-node RAC cluster setup, how we do it. And then coming to that original questions, what are the minimum IPs are needed? This is your node 1 and node 2. I need one IP address for this one. As I compare with my node here, I need one public IP. I can say this is my public IP, and this is my public IP, or node 2. Okay, this is I have config here. So this is your again public IP here. Right. So this is your public IPs, and these are your physical IPs. These are your physical IPs. I'll just list it out here. Physical IPs. So each node should have its own physical IPs. So for 2-node RAC, we need 2 physical IPs. The physical IPs are here: 110.38.9. Why it is 9? Oh no, it should not be 9. Okay, it should be 4 here. It's a typo here. Let me make it 4 here, because it should be on the same subnet. It's not a 9. I'll just make it right. It should be like 10.38.4.110 and then 10.38.4.1.115. These are the 2 physical IPs. I need 2 physical IPs, right? And then these 2 physical IPs need your VIP associated to that node. If I go here, these are my VIPs. For the same node, I have my VIP here, and then for the other node, I have my VIP here. You can see both are in the same subnet: 4.4.4.4, 10.38.4.138, 10.38.4.126. So I need node. This is a node physical IP. I can just make it some more clear here. It's a node physical IP, right? And then node VIP. We need a node VIP. How many node VIPs? We need 2 of them. Sorry. Node VIP. We need at least node VIP 2, because 2 nodes, it has its own individual VIPs.
Then comes to your scan. Your scan is here, 4.107, and then 4.107 is one of the scan. And then if I go to other node, I have you 4.154, 4.162. These are the 3 scan IPs. 2 are on my node 1, and then 1 is on node 2. So I'll just list it out here. Your scan. One is this one, second one is this one, and third one is on node 2. I'll tell you how, on what basis I'm telling these are my scan IPs. So scan VIPs. I need at least 3. You can go with more than 3. You can go with the 4, 5, 6, 7, whatever it is. But 3 is a minimum requirement. Below 3, you cannot configure your Clusterware. Right, you got your scan. And then your private IP. Private IP is again your VIP. Private VIP. I just say private VIP. How many I want? I want 2 individual to of those nodes. Node 1 also has 1 private IP. Node 2 also should has 1 private IP. If I go here, this is my private IP. Sorry, I'm wrong here. It's a private IP, not a VIP. Right, so I can go with 2 here. And then this is your private IP. I'll just mark it here. And then, sorry, this is for node 2. And then for your node 1 is here. Node 1 is here. Node 1 private IP is here. Right here. So if you observe, this is running under subnet 9. This is under subnet 9 here. So 2. So in order to set up a 2 node rack, these are your minimum required IPs. 2 node IPs, that's the physical IPs. 2 node VIPs, that's virtual IPs. 3 scan IPs, again those are VIPs. And then your 2 physical IPs, which are private. So altogether you need 6 plus 3, 9 IPs in order to do a setup of your 2 node rack. So your requirement is to, whenever you're setting up, because you are not going to get all the IPs, you're not going to configure IPs by your own, right? It's a network admin task. You are going to see that, I'm going to do that node, rack node 1, rack node 2. These are my, you're going to give the requirement to your Linux and your network team that I need a 2 Linux servers with the host name is this one and this one. And then your Linux admin will build a VM for you, and then he will provide. And then you should ask him, I need a storage, a common disk between these 2 nodes of 1 terabyte, 2 terabyte. Your Linux admin will provide. And at the same time, you're going to request, I need 9 IPs. This is my requirement. Each individual node has its own physical IP. Each individual node has its own private physical IPs. Each individual node has its own 2 VIPs. And then I need a 3 scan IPs. And then your Linux admin will define all these IPs in your domain or your DNS server, and then he will pass all the details. Then you can start with your installation. Right, any questions so far?
Hi, Malik. How
Yeah.
how can we identify which is scan IP, virtual
Right.
IP, private IP, physical IP? How can we?
All right. So no, this for the first time installation, your Linux, your network admin has to tell what are the node IPs, what are the physical IPs. Once your installation is done, then pretty much you can find it over here.
Yeah.
CRS-CTL stat resource -T. The
For
moment you
private, for private IP, we have the different subnet, right?
yeah, private IP, it's a different subnet, so you can get rid of this private IP. You can easily find it out.
Okay.
And only thing is your node IPs and then physical IP is easy to get it out. I can tell you how you can get the physical IPs. Right now you can see here, right? The moment you do IF config here on the node, how many interfaces are there in the particular node? First question, how many interfaces are there in this node 1? You have to look at this interfaces here. ENS 192, it's one interface. And then again, you can see your ENS 192:1. It's your kind of a VLAN. It's not an interface. It's a virtual VLAN here. Virtual interface it is. It's not an actual interface. And then ENS 192 is one interface. ENS 224 is one more interface. And then ENS 224:1, again, it's your virtual interface. You have to ignore this one. And then come back here, ENS
256. This is one more interface. So in this server, in this particular Oracle Lab 1, I have three interfaces: 192, 224, and then 256. I have a three interface here, and then always your ENS 192, that first interface in your lab or in your client machine, that is your physical IP of that particular node. The first interface, whatever you're seeing, that will be your physical IP of that particular interface. You can see this is 10.38.4.110. That is your public IP of that physical IP associated to that node. That's where we given here 10.38.4.110. 110, that is your public physical IP. That those are your physical IPs. You can find it out here. And go to node 2, same thing, ENS 192, that is associated directly. You can see ENS 192 directly, that IP will be associated to that interface. That's where you can find it out. It's a physical IP. Physical IP will always associate you to your interface. Your interface will have the physical IP always. And then come back to other interface here, ENS 224. You can see this is 9 series here. So this is your, again, a physical IP, but it's a private IP associated to this ENS 224. That is your private IP. You can find it out, your private IP and physical IP directly. How you can find out your physical and private IP? Just by doing ifconfig, and then your private IP, and then your physical IP will be directly associated to your interfaces here. Right? Again, you can see 192 directly associated with this physical IP, ENS224 directly associated with this private IP. That's where you can identify your physical IP and private IP. Now coming to your node VIPs and scan VIPs, how to identify your node VIPs and scan VIPs? The name itself indicates these are your VIPs. VIPs will never have interfaces. You can see like your VIPs will VIP will be tagged to any one of your interfaces. Whatever the interfaces you have it, they will be like virtually attached to those interfaces. You can see ENS 192:1, and then I have attached my node VIP here. And then go to node 2, ENS 192:1, and then I attached node VIP here. Node VIPs are associated to that interface, whatever that the physical IP assigned to that interface. To that interface, your node VIP will be assigned. Node assigned, those will be like floating. Those will be like virtually attached to those interfaces here. So those are your node VIP, 2 node VIPs. And then again, scan VIPs, 3 scan VIPs. Again, those 3 scan also on the same subnet, right? 4.series, the same subnet. Again, they have to associate it to the same interface. For example, 192, ENS 192:2. This is one of my scan IP. And then go to node 2, ENS 192:3, and then 5. Again, these are the 2 VIPs. These are my scan VIPs associated to that same interface. Why all these your scan and VIPs, node VIPs and scan VIPs are tagging to the same interface? Because this is your this is the interface where your physical IP is associated to that. And then all your VIPs and scan VIPs running under the same subnet of your physical IP, they have to tag to that same interface with the virtually it will be tagged here. And then just by doing your crctl stat resource -t, then you will get to know your scan 1, scan 2, scan 3. You can see your scan 1 running under node 2, and your scan 2 and 3 are running under node 1. 2 VIPs are assigned with the node 1, and then 1 VIP is assigned with the node 2. That's where you can see here only 1 scan IP is attached to this interface. And then coming to node 1, you can see 2 scan IPs are assigned with here. 192:3:5. These are the 2 scan IPs are assigned to this particular node 1 here. Right, so that is how you can verify it at high level. Otherwise, there is a scan commands. You can pretty much find your what are the scan IPs, and then what are the let me open this here. These all commands we're gonna practice it as part of our admin guide, how to find the scans and all. It'll be like part of your wait a second.
not at this point. Like, the moment you ask, many people will, get confused at this moment. Now you can do this simple command, right? srctl config scan. This is one of the command, srctl config scan. The moment you do srctl config scan, that pretty much will tell you what are your scan IPs. srctl config scan. You can see your scan IPs 4.216, 4.154, 4.169. That's where I listed out here. 154. You can list out, right? 154, 162, 170. So these are your scan IPs. One IP is different here. 170. Is that the correct IP I copied? Let me verify. Where is that one? 150, 162, 154 on the other node. Okay, 170. No, this is not the IP. This is the actual IP. No, not this one. Okay, this IP is got changed here. This IP is got changed. 170. Ideally, it's supposed to be. I need to restart my backend network. This IP in the scan, it is still registered with 126, but this is the old IP. I need to change it here. So these are your scan. Like pretty much you can run this srctl config command, and then on any of the node, that will give you all the scan IPs. That's the one thing you can verify your scan IP. And then similarly, you can verify your srctl scan your VIPs, and then that also will give you your VIPs. What are the VIPs? Pretty much we can cover them once we start our actual class. Right. Going back to our slide here. That's one of the common questions. How many IPs are needed in order to set up a 2-node rack? Pretty much answer is 9 VIPs, 9 IPs, including all your physical VIPs and then virtual IPs and then the private IPs. Right, and then one more concept, scan. We'll quickly cover the scan, how the scan works. Your client will connect using the scan host name. The moment he connects scan, the scan will be having a 3 IPs. It will be like assigned with any one of the IPs. And then the scan will internally pass the connection to any one of the surviving node, any one of the cluster nodes to that particular node VIP. If I go back here, or else you can go back here. Okay. Your client will connect via mobile. He will connect using the scan host name. This will be scan host name. Scan will be assigned with any one of the IP. Via scan, that will connect to that particular node VIP. The client connection will go to scan. Via scan, it will connect to that node 1 VIP, and then it will connect to node 1. And then the moment this particular node goes down, if this particular node goes down, what happens? If this node goes down, and then your scan is smart enough, or your rack cluster will try this client connection who is connected to node 1, he will connect to node 2. Because from the scan, he will be connected to a node VIP. And then this node VIP is a virtual IP. The moment node goes down, that a public physical IP which is associated to that node will go down, because this is a physical IP associated to that interface. If the node goes down, that physical IP will be down. This physical IP will be down, not accessible at all. And then whereas the VIP associated to that particular node 1 is a virtual in nature, that will be like floating in your cluster. It will be like floating, and then this IP will be tagged to any one of this node. This VIP will be tagged to any one of this node. And then the moment it will tag to any one of this node, the whatever the client connection connected to node 1, it will be like connect to any one of this node 2. That's where always can pass the connection to your VIP. From the VIP, it will connect to that node 2, node 1, and then it will access to your database. Assume that from the scan, if it is connected to node physical IP rather than node VIP, what happens? If it connected to node physical IP, if the node goes down, this physical IP will not be accessible. Physical IP will be down. All the client connection will be disconnected. Client has to reconnect back again. So that's the beauty of your node VIPs. Your scan will pass the connection to node VIP, and then
If in case node goes down, only that physical IP will go down. Your VIP will be switched to any one of the surviving node. And then that client connection will be handed over to any one of this node, wherever it will switch over. That's where your VIPs are very, very mandatory in order to, do a failover. For example, if I want to show that one here, right now CRSCTL stat resource -t. If you see node 1, right, where is the VIP here? Node 2 VIP. Right, you can see this node 2 VIP, which is online running on this node 2. Your node 1 VIP online running on your node 1. Now I'm going to shut down my node 1 here. CRSCTL stop CRS -f. I'm going to shut down my node 2 clusterware. Entire clusterware is going to down here. The moment node goes down here, your scan and your VIPs of this node will be switched to node 1. You can see here, right? Where is that one? Let's complete. I will show that one. Right, you can see this one, right? These two words here. Attempting to start your VARA scan 1 VIP on node 1. Attempting to start your node 2 VIP on node 1. Whatever right now running on node 2, the VIPs will be shifted to node 1. If you have multiple rack cluster, it will go to any one of the node. And you can see start of your node 2 VIP and node 1 is succeeded. Start of your scan 1 VIP and node 1 is succeeded. If I go back here, your node 2 VIP associated to node 2, obviously, and then it has now shifted to node 1. And then your scan, where is the scan? Okay, your scan 1, which was running under node 2, now that also shifted to node 1. If I go to node 2 here, node 1 now, if I run the same command here, crctl stat resource -t, you can see this one, Oracle node 2 VIP online intermediate, and then it is a failed over, and then it is stable. So this is ideally node 2 VIP supposed to run on node 2. Since that node 2 cluster is down, the physical IP is down, it is failed over to that surviving node, that is node 1. If it's a 4 node, 5 node cluster, this node 2 VIP will go to any one of that surviving node. And then you can see your scan 1, now it is running on node 1. So that's the beauty of your scan. Like, end user client will continue to work, continue to establish his connection, and then he will be continue to work. That's where scan will connect via node VIP, and then it will connect to your database. If the scan is connected to physical IP, if the node is goes down, all the client connection will be disconnected. Client has to reconnect again. So just to avoid that, your node VIPs will be very, very helpful. Right, so that's about node VIPs, and few more things. Shared storage. Let's quickly connect to shared storage here. Let's go to dev LLSD star. You can see these are your SDA1, these are your OS disk, and then these are your shared storage here. Your SDB, SDC, SDD, SDE, these are your shared storage connected to node 1. And then similarly, if I go to node 2, LLSD star, you can see your SDB, SDC, SDD, SDE. These are again same physical or same virtual disk mapped to both the nodes. And then you can connect your ASM, and then you can check all the disks are associated to common storage. If I do this .varinv plus ASM1, and then here I will connect to Oracle .varinv plus ASM2. I can do ASM CMD -p and then do LSDG. Okay, ASM is down here on node 2. ASM CMD -p LSDG. I can list the disk group. I have a data and record 2 disk group. If I go inside my data, and then I have both the databases. You can see RAC databases, RAC standby, and then test DB, both the databases. And then if I go any one of that database name, and then it has its own individual control file, data file, parameter file, password file, temp file, and all those things. These are your shared storage both the nodes are able to access those disk groups. If you go here, data and reco, these are your ASM disk groups. Your both the instances, test DB1, test DB2 are able to access. These are your common disk groups. So you can pretty much find out all the OCR other files inside your disk groups, your data files, control files, SP files, redo log files, archive log files, flashback logs, dump files, your BCT, your RMN log, your OCR routing disk, everything you can see it in your SM disk groups. And then cache fusion, already as I explained, if you want to access the block, data block, which is available in any one of the node, directly it will transfer using your private network. That's your cache fusion. But some of the other background processes and then the cluster startup sequence, probably we can stop it here, and then tomorrow we'll start with this cluster startup sequence and some of the some more background process and other things. Any questions so far? If any questions, feel free to ask me now, or else we can stop it for today, and then tomorrow we'll continue with some of the administration of your files, your routing disk OCR, and then your instance level SP files, your redo log files, and other things we'll understand. And also we'll see some of the clusterware startup sequences, how we can start the sequence, and then how, for example, here on node 2, the cluster is down. If you do ps-ef grep smon, we just brought it down, right? CRS-CTL stop CRS-f. Now if I do CRS-CTL start CRS, it will start. And then what is the startup sequence? If I do start, it will start your all the clusterware. And then what is your startup sequence? So this is how its startup sequence works. So we'll explain all of them in our tomorrow's demo class. Right. So any questions so far? Anything, feel free to ask, or else we can stop it here for today.
Hello, sir.
Hey, yeah.
Yeah. Sir, there is a, I think, significant role for MTU values, right? For communicating between the two nodes.
Right,
So,
right.
So
Each,
can you please highlight that one?
Yeah, probably we can take it once we start our class. MTU, again, default, it's a 1500 or 15,000. So again, each of them will be like having, based upon your network setting, 1500 is a default with all the interfaces. So you can increase this MTU value, or you can decrease this MTU value. I'm going to explain it in probably tomorrow, or probably once we start our regular classes, I can explain this MTU value. This MTU value is very, very significantly impact your cluster node communication. The moment you change this MTU value to, now it is a 1500, make it to 10, make it to 1500, make it to 1000, or make it to lesser than 1500, your cluster nodes will start getting eviction. Your node communication will not happen properly, and then your nodes will start evicting each other. Like node 1 will say, okay, I'm not able to get a proper response from you, get evict. And then node 1 will say, okay, I'm not getting a proper response from you, like please evict yourself. So that will lead to your node eviction. So you have to at least go with a 1500, or more than 1500. So that I will cover how we can define your MTU settings, and on what basis you're going to define your MTU setting.
Okay,
right. Any questions?
Sir, what is the minimum hardware requirement for personal lab setup, sir?
We need a minimum of 16 GB RAM in order to work properly. 16 GB RAM, and then pretty much 100 GB hard disk is needed. 15 GB RAM, because if you want to practice the installation, that's setting up your cluster rack and all, if you want to do it from the scratch, 16 GB is pretty much needed. If not, if you want to just to use that ready labs, you can even work in lesser than 16 GB, just download, configure it, but it's very, very, very slow. 16 GB is the minimum, bare minimum RAM needed in order to work in your laptop, and 100 GB hard disk. Right. Any more question? Right. If not, then we'll connect tomorrow, guys, at the same time. Thank you, everyone.